All right, this is Coach Suiso here, and I'm going through the answers to the pre-lab questions for the analysis of a mixture lab. So hopefully you did these last night in preparation for your lab today, but I always go through these questions before we actually do the lab because it's imperative that you get these right. Because if you don't understand the process and what it is that you're actually doing here, then the lab is sort of a moot point. You can't actually do the lab correctly. So as you know, you're getting a bag with both sodium chloride, which is table salt, and sodium bicarbonate, which is baking soda, and you don't know the percentages or the grams of each. It's an unknown to you, and so your task is to determine what those are. So you know that acetic acid does react with sodium bicarbonate, right? Like think elementary school volcanoes. And sodium chloride does not react with acetic acid. That's given to you in your background information. So the first pre-lab question says to write the balanced equation for the reaction between the acetic acid and sodium bicarbonate. And it says, remember that carbonic acid decomposes as it forms into CO2 and H2O. That's something that you should know from hopefully your CAP chemistry year when you did special synthesis and decomposition work. So this is the balanced chemical equation. So we got our sodium bicarbonate reacting with acetic acid, which is HC2H3O2, also known as vinegar. And then you've got CO2, H2O, and sodium acetate as my salt there at the end. And then also note that it's a 1-to-1-to-1-to-1-to-1 ratio across the board there, so it's very easy to balance. Then number 2 says household vinegar is 5% acetic acid, which means there are 5 grams of acetic acid in every 100 grams of vinegar. That's an important piece. You'll need that for your dimensional analysis. It says use DA to determine the mass of the vinegar that would react if you had 20 grams of sodium bicarbonate. You don't know if you have 20 grams of sodium bicarbonate. You don't know how much sodium bicarbonate you have. However, this is the math that you're going to use in order to determine how much vinegar you're going to need to react with your baggie. So this is how I set it up. I use the train track method. You haven't kind of had me going through this with you at the beginning of the year, but this is how I set up my dimensional analysis. So I my 20 grams of my sodium bicarbonate, and then I converted that to moles. Then using my balanced chemical equation, I have a mole to mole ratio. Convert it to grams of my acetic acid or my vinegar. And then this is the most important piece, is this last little bit over here where I have to actually determine how much acetic acid is in the vinegar. So for every 5 grams of the acetic acid, I have 100 grams of vinegar, which leaves me with 285.9 grams of vinegar that I would need to use to react if I had 20 grams of sodium bicarbonate in my bag. No one should have that much in your bags. Your bag should weigh about 10 grams total. So this would be a ton of vinegar if you ended up getting this. But in this hypothetical situation, that's how much vinegar you would use. Then number 3 says you're given a mixture of baking soda and table salt and its mass is 8.35. So actually that's more realistic, right? If the mass percent of the baking soda in the mixture is 14.2%, what mass of carbon dioxide would be produced? So this is just a very basic stoichiometry problem. The first thing that I did here was I figured out how many grams of the sodium bicarbonate I have. If I have a total mass of 8.35 and I know that it's 14.2%, times by its percent, and that gives me 1.1857 grams of the sodium bicarbonate in the bag. And then that's my given. So I take my sodium bicarbonate, I change it to moles, use my mole to mole ratio, and then I convert it to carbon dioxide, and I should produce 0.62 grams of carbon dioxide. So take a minute, make sure that your work is correct on this before you start the lab. Obviously, your numbers when you do this math for the lab on the second page of the lab sheet will be different than these, but the process is still the same. And you don't just want to copy the process. You want to make sure you really understand it because that will be helpful for your exam in a week or so, okay? Hopefully that helps. Good luck.